So, all right. Well, good afternoon. I'm Terry Harbour with GridSME, and we're excited to share some information with you on NERC standards PRC-28, 29, and 30, and what this might mean to you. Sarah went through the housekeeping, so what we'll do is we want to give you a standards overview and how these standards fit together. And then we want to do a quick dive into each standard and the requirements, some technical points that you probably want to be aware of, and some common challenges that we're seeing, and some actions you can take to be compliant. And of course, we'll try to summarize at the end. After this webinar, we hope that you take away the understanding and purpose and scope of PRC 28, 29, and 30, that you're able to identify some key technical requirements and your compliance deadlines, that you can recognize roles and responsibilities for monitoring, ride-through, and event reporting, and that we can give you some actions for compliance and evidence collection. So with that is, how did we get here? As far back as 2016, NERC began identifying inverter-based resources events and developing reports, and that inverter-based resources were a little different. Unlike synchronous rotating generators, which are magnetically coupled to the grid, inverter-based resources are asynchronous, meaning they're more predominantly driven by their controls and their protections. So that doesn't mean they don't interact with the grid. It just means those controls tend to predominate. So NERC realized that these inverter-based resources needed their own standards and requirements, which sort of leads us into PRC 28, 29, and 30. They're all connected. They all sort of work together. PRC 28 is your base requirement, and it enables you to be able to meet PRC 29 and PRC 30. Again, PRC 28 is that basic equipment monitoring standard, which is talking about capturing disturbance data using sequence of events recorders, fault recorders, dynamic disturbance recorders. It's talking about where you put this equipment and the capabilities that equipment needs. Once you have that equipment in place, that helps you prove that you are writing through voltage and frequency events for NERC standard PRC 29, and that you are identifying loss of the power plants or change in power events, which NERC wants you to analyze and determine whether there's corrective actions, etc. So PRC 28 helps 29 and 30 work, and they need the equipment from PRC 28. So that also means the implementation timelines are sort of connected at the hip. And some information on how to sort of walk through these implementation timelines or deadlines is we look at, are you a Category 1 plant or a Category 2 plant? Now, really briefly, Category 1 is your traditional bulk electric system power plant. It's rated at 75 MVA or more, and it's connected at 100 kV and greater. Category 2 plants are new and they're smaller, and they may be connected at 60 kV and greater, and they might have a range of 20 MVA to 75 MVA. So that's your smaller Category 2 plants. The next piece of information that sort of drives your implementation timeline is your commercial operations date, and we'll talk a little bit more about that later. And how you're registered with NERC. Do you have one plant for your NERC registration, or do you have a whole fleet under that same NERC compliance registry number? So we'll just go through an example of walking through a timeline for NERC standard PRC 28, a Category 1 power plant. So you start out with, if I am a Category 1 power plant, yes. If not, I'd go to a Category 2 screen. And next is, what is my commercial operations date? And NERC drew a line in the sand for April 1 of 2025. If you have a commercial operations date prior to that, they figured you might need more time to retrofit and upgrade your equipment, and therefore they were going to give you some more time. You would next look at, how am I registered? If it's a single plant, which probably most are, your first deadline is, I need to be compliant with installing my equipment for PRC 28 by the end of 2028, which is 12/31 of 2028. If I happen to have a fleet, let's say you've got 4 plants, they're all under that same NERC compliance registry number, they'll want 50% of your plants done by the end of 2028, and they'll want the remainder done by the end of 2029 because FERC said everything has to be done by January 1 of 2030. So going all the way back to that compliance or your commercial operations date of 4/1, if you are on 4/1 or later, you have a shorter deadline. You have to have your equipment installed and ready and operational by July 1 of 2026. If you've got a projected commercial operation date after that 7/1 of 2026, you need to be compliant when you come online or by your COD date. So that would be an example of a Category 1 plant for PRC-29 or PRC-28. Looking at PRC-29 and 30 timelines, after you've determined whether you're Category 1, the next thing is there's a branch here that relates to what's called a PRC-29 design requirement. And that means PRC-29 is going to force you to prove that your design is capable of meeting the new voltage and frequency ride-throughs by updating your models and simulating. So that's sort of a new step, but that's something that you have to do. And that is a design requirement. After that, you move into your operational requirements. And those operational requirements sort of rely on your PRC-28 equipment installation deadlines. So you sort of wait until those are in place, and then you have to be compliant with the operational requirements for PRC-29 and 30. So hence you see sort of a do loop of no, my disturbance monitoring equipment isn't installed yet, and your deadlines become either the later of 10/1 of 2026 or when I install my equipment. And then we just put all 3 timelines sort of together so you have it in one place. It's pretty busy. That's why we thought we'd break it up for you. To run through a quick Category 2 example for PRC-28, yes, I'm a Category 2 power plant. NERC chose a different line in the sand or different date that they want you to look at. And that is if you have a commercial operations date before May 15th of 2026, you have until the end of 2029 or 1/1 of 2030. If you have a commercial operations date after May 15th, you're going to still have that July 1 of 2026 deadline. And again, if you've got a commercial operations date after July 1 of 2026, you'll have to be compliant when you come online. The PRC-29 timelines are very similar to the structure of the Category 1s, except for you've got different deadlines. For the Category 2 plant, you have to prove your design meets compliance to PRC-29 by January 1 of 2027. And then that corresponds to your operational requirements being the later of either 1/1 of 27 or when you install that disturbance monitoring equipment. So, and then we've put those timelines together for you. So, all right, that leads us into NERC standard PRC-28. We want to take a look at that standard. And the purpose for this requirement is to detect and record voltage, frequency, and power disturbances using equipment such as sequence of events recorders, fault recorders, and dynamic disturbance recorders. And once this equipment is in place, you're supporting your capability to show you're compliant to PRC-29 voltage and frequency ride-through events, and you're also enabling PRC-30 event reporting. All right, looking at some key technical points for the NERC standard PRC-28. First of all, requirement 1 is your sequence of events reporting capabilities and data. Requirement 2 talks about your commercial operations date again, and I'm going to use a Category 1 if deadline of April 1 of 2025. And this determines whether you must put in sequence of events recording for each individual inverter at your power plant or not. If you're before that 4/1/2025 deadline, or I think it's May 15th of 2026 for category 2, and you can show your inverters are not capable of providing the data required, then you can get out of that requirement. But be aware, NERC will want you to prove that. So make sure that you can justify that my inverters can't meet this requirement. So requirement 3 for PRC-028, this is your fault recording data and specifications. Some issues that we're seeing is that it's got some faster speeds, like 64 samples per cycle. It's also got a long, what's called a fault recording record length, a total record length of 2 seconds. This could be problematic if you've got relays performing this function, and especially older relays. So it may cause some issues, so just be aware of that for requirement 3. Requirements 4 and 5 are capturing dynamic disturbances data and equipment specifications. Requirements 6 and 7 is your time synchronization requirements. So your equipment must be time synchronized to what's called UTC, or Coordinated Universal Time. And as an example, your substation equipment for PRC-028 has to be UTC time synchronized to plus or minus 1 millisecond. Other possible key technical issues is gathering all of this data and storing it for at least 20 days, and maybe longer if you've got a regional requirement that supersedes NERC. You can get some regional requirements that are above the NERC standards. So you could have a phasor measurement unit requirement in ERCOT, and it might require a plus or minus 100 microsecond installation. So for evidence, think about your installation. Think about your installation records and schematics, specifications, logs, and event data, and keeping that data for at least 3 years. Now, requirement 8 is your equipment loss requirement. So there's 2 parts to requirement 8. There's a plan piece that is required by January 1 of 2026. And then there's an operational piece once your equipment is installed. So thinking about that plan piece on January 1 is make sure that you write down your plan for equipment loss in the future. And that could be a manual plan, it could be an automatic plan, or it could be both if you wish. An example of a manual plan would be just adding some checkboxes to your substation monthly rounds, confirming that yes, my disturbance monitoring equipment is active and operating. So check, yes, and providing that or keeping those records every 30 to 60 days to make sure that you are verifying your equipment is active within 90 days. An example of an automatic plan could be pulling SCADA data back to centralized locations, whether your operators know, is my equipment functional? Is it on, off, enabled, disabled? Do I have power? Do I have signal? Those kinds of things that make sure that you know that the equipment can do its job. So that's once you have written down your plan and identified your plan, once that equipment goes into service, then you'll have to think about operationally implementing that plan, which is, did I detect an equipment loss? And then the next step would be is, okay, well, I'm going to get together with my field and my engineers, and they're going to confirm that there was a loss discovery. If you discover that there is a loss, yes, this equipment really is dead. That starts a NERC 90-day clock. And then you're going to have to decide whether you're going to restore that capability within 90 days or develop a corrective action plan and report that to the regional entities. So thinking about evidence, think about your installation logs, your automated and manual check logs, your corrective action plan documentation and data logs, and keep this information for at least 3 years. Key challenges for PRC-028 is there's a short implementation window, especially if you have that April 1, 2025 deadline or longer. You have to have that equipment in place by July 1 of 2026. It's likely these standards sort of are enhanced, so you might need additional equipment upgrades, hardware, firmware, software changes. We had mentioned earlier those fault recording sampling speeds of at least 64 samples per cycle, those total fault recording lengths of 2 seconds, that could cause you issues. The time synchronization can be tough. And coordinating each individual inverter across your entire plant, that could pose some challenges. That's where you might want to again talk with your engineering team to say, hey, this is difficult. Can I do this? Gathering and keeping all of that data for 20 days or more, and recognizing any regional requirements can be key challenges. So for evidence, think about your installation specifications, your event logs, if you have any failure or restoration logs, any corrective action plans, submissions to regulators, and data submissions. So thinking about actions that you can take to be compliant is the first is, again, developing that plan by January 1 of 2026 and writing it down. You might specify who's in charge. It's my field people or vendors doing this for me if I've got a manual plan, or it might be my operators if I'm pulling data back to a control center. Next, think about your requirements 1 through 7 and those equipment installation deadlines, and back up. You'll want to get in to the field early and work with your vendors and your manufacturers early to make sure, hey, this is what I've got in the field today. And then you're going to want to assess where you are. You might want to walk to your engineering firm and say, okay, guys, this is what I've got. Do I have any gaps to NERC standards PRC-028 and of course 29 and 30 because they all work together? And if I do have gaps, give me some solutions, and you're going to want to put those together and make sure that you meet that equipment installation deadline. So once that equipment is installed, make sure that you are monitoring and maintaining that equipment. If there's an equipment loss, make sure you respond to that loss, implementing your plan that you put in place in January 1 of 2026. Again, is it my field found that this equipment may not be functional? Yep, I verified it doesn't work. I'm going to determine whether I'm going to restore it within 90 days or develop a corrective action plan. Those types of things. And then make sure that you're keeping and retaining all of your evidence. So that's going to take us to NERC standard PRC-029. So the purpose of PRC-029 is ensuring that your inverter-based resource plants can survive or ride through a voltage and frequency excursion. Requirement 1 is that design requirement that we mentioned earlier that's going to require modeling and simulations. And we'll get into sort of some timelines here a little bit later. Requirement 2 is your voltage ride-through requirements. Requirement 3 is your frequency ride-through requirements. And requirement 4 is identifying and documenting known hardware limitations. We'll talk about that a little bit more as well. So key actions, and these are not NERC timelines, sort of get into the field early, work with your O&M provider, work with your manufacturers, work with your engineering firms to assess what you have. Here's what I have. Work with them to say, okay, are there any gaps? Do I need to make any equipment upgrades? Do I need to make any settings changes? And get a solution from them. Make any of those needed changes to your relays or controls. Once you feel you're in a good spot, you may need to find an engineering firm to update your power, or you probably should find an engineering firm to update your power plant models. And then begin simulations, maybe in that April 1 to June 1 timeframe. And then you'll want to run those simulations to verify that your designs can indeed ride through voltage and frequency events, all prior to that 10/1/2026 deadline. Once you are operational, then you're going to want to monitor that plant performance for problems or unexpected trips. If there is a frequency or voltage event, you want to pull data and show that you were compliant, or and You'll just want to analyze the data. So for evidence, think about equipment lists and settings, simulations, study reports, updated plant models and settings, and any events and data that you might need. So again, jumping back to those milestones or timelines, again, get in the field early, think about gathering your data and assessing where you are by 1/31 or the end of July or January, I'm sorry, of 2026. Then make your model updates and begin your simulations in that April to June timeframe, and then verify that your designs can meet PRC-29 by that 10/1/2026 date. So those are some key actions. And that's for 1 through 3. And requirements 4 is identifying, documenting, and reporting known hardware limits that would prevent you from complying with requirements 1 through 3. So for this, you'll need to work with your manufacturers, your engineering firms, maybe your EPCs, to identify if there's any hardware limitations out there that would keep you from meeting one of the requirements. As an example, your inverter may not meet what's called a rate of change of frequency capability of 5 volts per hertz. In this case, you'd want to reach out to your manufacturer and you'd say, hey guys, can my inverter do this? Hopefully they say yes, and here's your design spec that says you can do this. Maybe they say no, you can't, at which point you want to say, okay guys, why can't I meet this requirement? And I'm going to need a technical justification for NERC. So make sure that you're reaching out to your manufacturers and your engineering firms soon on this to identify these, document these, and then you will need to submit any documented limitations to NERC and the applicable entities, all by 10/1 of 2026. So for evidence, think about your manufacturer statements in the positive, yes, you can do this, or no, you can't, and the technical reasons why. Think about damage curves, technical reports, and any submissions and confirmations to and from regulators. So key challenges for PRC-29 is model building and performance simulations are new. They're complex, they're time sensitive. PRC-29 is an enhanced ride-through, I'll say, compared to NERC standard PRC-24. And you do have longer time durations and slightly larger frequency ranges. So even if you were compliant with PRC-24, which I believe was a 4-second standard, PRC-29 might require ride-through up to 1,800 seconds as one example. So even if you're compliant with PRC-24, you may need to check to see if you're still compliant with NERC standard PRC-29. PRC-29 also adds reactive current prioritization requirements, which can be complicated. Then you have to identify those known hardware limits, and that can take time as you work with outside parties. Firmware, software, protective settings may obscure some of those hardware limitations. And anytime you are updating protective settings, you may trigger another NERC standard, such as NERC standard PRC-29 or 19, and you might have to do an updated study within 90 days. So for evidence, think about your field settings, your updated models, your simulation reports, any manufacturer correspondence, and any event data that you might be collecting. So back to those actions, again, back to the data gathering, make sure that you are ensuring that you know what you have and getting those solutions in early so that you can move to your modeling phase in that April through June timeframe, update those models, begin your simulations, make sure that you're compliant prior to 10/1 of 2026. Again, that's a Category 1 deadline. Once you've proven that your designs are capable of riding through by that 10/1 date, you can get into your operational implementation actions, which is anytime there is an event, pull that data, keep that data for 3 years to verify that you're compliant. And then another action is continuing to watch those hardware limits. If there's any new hardware limits discovered, or let's say you retire one, regulators want to know. So those are some actions for PRC-29. Thinking about PRC-30 next, is the purpose of PRC-30 is to ensure reporting of your entire plant or facility loss and change of power events being the greater of 20 megawatts or 10% of your plant's nameplate capability. Requirement 1 is that event detection requirement. So they're going to want you to detect your plant loss or these change in power events. Once you've detected an event, they're going to want you to do an event analysis in requirement 2, develop corrective actions in requirement 3, and implement any of those corrective actions in requirement 4. Key actions for PRC-30 is to monitor that plant output continuously over a 4-second window, to detect your plant loss or that change in power events, and to confirm those events are valid before initiating more work under PRC-30. And that might be a cloud passing over your solar array and suddenly reducing power may not be a PRC-30 event. Loss of wind suddenly may not be a PRC-30 event. Or if you have a freezing issue, that may be an EOP-12 event, but maybe not a PRC-30 event. So there's going to be a couple more recommendations on that later. So for your evidence, think about event data, equipment loss, specs, and schematics, your monitoring logs, your SCADA outputs, your event detection, and procedures. So thinking about requirements 2 through 4 after requirement 1, these are more procedural. This is where they want you to analyze events, to develop corrective actions, and implement those. You need to conduct that event analysis within 90 days. Once you're done with that and you've determined you've needed corrective action plans, that's required within 60 days. And then you have to implement those corrective actions by the timelines and deadlines that you specify. You'll also need to notify the proper entities. So for evidence, think of event analysis reports, corrective action plan documentation, notifications, work orders, maintenance records, and I think that's it there. So PRC-30 common challenges. That's, again, designing this rolling 4-second window may be a challenge to detect those change in power events. You may need additional data to ensure that it is a valid event. Again, if it's cloudy or a cloud came over, you might need some kind of irradiance sensor to help you determine, nope, it was a cloud, it wasn't an equipment issue. You might need wind speed to do the same for wind. Nope, it was a wind speed issue, it wasn't an equipment issue. Or you might need temperature data to determine, nope, something froze and it wasn't a PRC-30 issue. And of course, this standard requires a lot of coordination. Anytime you have one of these change of power events, you've got to think about, working with your field and your engineering people and compliance steps. So it takes a lot of coordination. So evidence are your event detection procedures, SCADA logs, device configuration records, and event data and analysis reports. So back to some action plans. Thinking about actions you can take is be ready to implement that PRC-30 process. Be ready to confirm that it's valid. Once you've confirmed that it's a valid event, make sure that you conduct that event analysis within 90 days. And then you develop any corrective actions, if required, within 60 days. And then you follow and finish that corrective action plan according to the timelines that you specify. So you want to keep evidence of all of the work orders and changes and things that you did to complete that implementation plan as evidence. So in summary, these standards are complicated. They all sort of work together, and they're focusing on collecting disturbance data. Once you're collecting that disturbance data, you're verifying that you can ride through voltage and frequency events and that you can detect and report change in power events or loss of your facility. For core compliance actions are, be aware of your timelines to install and then monitor that disturbance monitoring equipment. When events do occur, make sure that you're validating that you are writing through those voltage and frequency events correctly, and detect, analyze, and correct any change of power events. And as always, work together. It's the GO that's watching the compliance oversight. I'm sure they're getting assistance from the field as necessary, and engineering is probably helping develop any technical issues or identifying root cause issues. And make sure that you're aware of your compliance deadlines, as we went through some of those examples early. And as always, your keys to success is get into this early, work with those field people, work with your manufacturers to engage, get that data, assess where you are, and then you can move forward with installing equipment and then verifying that you're compliant. So that was a lot of data that I threw at you. And for that, after that, I think I'm done with my presentation, and I'll be happy to answer any questions that I can at this time.
Awesome. Thanks, Terry. All right, for all participants, I'm going to go ahead and unmute everybody, or at least give everyone the option to unmute yourself. If you do have a question and you don't want to talk, go ahead and type that into chat. I'm happy to ask the question for you. If you also have a question and you do want to talk, go ahead and raise your hand using the feature within the panel, and we will go through kind of whoever raises their hand first. We'll just go down the line. So open for questions for anybody. Don't be shy. If you have a question, likely other people have the same question or a similar question.
I have a quick question. Hi, Terry. This is KK from.
Hey, KK.
Hey. Yeah, my question is on data capture. Is there like a template that we can use for data capture? And what would be the frequency of uh, collecting the data? Is it once every 30 days, 60 days, and 90 days?
You bet. It sounds like you're talking about PRC-028 and requirement 8, where you are verifying that you did not have any equipment lost within 90 days. Does that sound right?
That's correct.
Right, right. So we're sort of recommending a 30 or 60 day monitoring or cycle, because it's sort of clear that NERC wants you to verify that your equipment wasn't lost within 90 days. So if you do it every 30 days or every 60 days, you've got a chance to sort of recover. And you were talking about what kinds of data to capture? Did I understand that
Yeah,
right?
is it like a checklist or template? What kind of data that we need to capture?
Sure, sure. We can work on a template for you along those lines. And an example would be is if you've got a manual plan and you're adding disturbance monitoring loss checkboxes to that substation monthly rounds, you could have your field people or your vendors identify, I looked at my sequence, or I looked at my disturbance monitoring equipment, and I verified that they're functional, and I'm going to check the box. And you can keep those monthly or 60-day reports as evidence that, yes, I'm checking within 90 days. And then you could also sort of proves, like, if there is a problem, I would detect it and then I would do something about it. You could also think about SCADA data. So if you are bringing back some functional points from those disturbance monitoring equipment, is it on or off? Is it enabled or disabled? Does it have power? Does it have signal? You could pull those statuses back. Your operators could maybe print or capture that every 30 or 60 days and say, yep, all of my equipment was working. And then if they got any alarms, that would be proof positive that yes, we are monitoring, and when something happens, we're doing something about it. Does that help?
Yeah, it's helpful. On the second part, if we plan to capture the data automatically through EMS data,
Hmm.
uh, can you like recommend like what key points that we should be looking at? Uh, I think doing it automatically probably will be more sustainable. We certainly can do that. So, but like in terms of what data points, right, that we should be recording, we should capture, would we get some guidance on those?
Sure. So you're asking what data should I pull back into my SCADA system?
Correct.
Alrighty. Well, I mean, something that you feel that can prove to an auditor that says, yes, my equipment was functioning. It could be, again, status points. Is it enabled or disabled? Is it showing that it's got power? Um, and then maybe some ancillary evidence would be is if there is an event, then you can sort of show that, yes, that's working. But
But
I get to your,
technically, if the
yeah.
site is online and then is following dispatch commands from the ISO, then technically, is it enough to demonstrate that the site is working, all the equipments are working well, or do we need to like pull specific key points from the SCADA to prove that there's nothing wrong with the equipment?
Right. I don't think NERC specified that you must have points A, B, and C. So to your point is if you have this and you think that it can prove that my equipment was functional, then you can gather that.
Okay.
I don't think they were specific on that point.
Okay. Thank you.
Yeah, great questions, KK. Does anybody else have questions? And again, feel free to type in chat, or if you want to unmute yourself and ask live, go for it.
All right. Did anybody have any questions on their implementation timelines, some of the data that they're interested in?
All right, not seeing any new questions coming in, so
Nope.
I guess we'll go ahead and wrap up. So if anybody does have a question later, if you think of something, feel free to reach out to us via email.
Can,
Happy to ask those questions. Oh, I think someone has a question. Go for it.
can you hear me?
Yes.
Yes, we can.
Yeah. In terms of return information or how long we have to store the data, it depends of, you said, the region, right?
For NERC, I believe it's 20 days. If you are an ERCOT, it may be longer. I'd have to double check, but I believe it could be up to 30 days. And I think you could
Oh,
look at the nodal operating guides. I think section 6.1.4 talks about disturbance monitoring equipment in those nodal operating guides. And you guys can correct me if I'm wrong.
I just wonder, the dynamic disturbance recordings is related to the phasor measurements, or it's different information?
That is a really good question. I suppose if you have one piece of equipment that has both that phasor measurement unit data and the dynamic disturbance recording data, that it can provide both functions in one piece of equipment. A technical difference, and my engineering people may have to correct me if I'm wrong on this, is the sampling speed. While dynamic disturbance recorders are really fast, phasor measurement units might be even faster.
Okay, but there's a requirement, right, to retain phasor data measurement per NERC?
Not NERC.
No?
NERC is just sequence of events recording, fault recording, and dynamic disturbance recording, and that may have been a little bit confusing. If you're an ERCOT, there may be a phasor measurement unit installation requirement as well.
Oh, okay. All right,
Thank
sounds
you.
good.
It's a great
Thank you.
question. I appreciate that.
Thank you.
Great. Any additional questions? All right. Well, before we completely wrap up, if anybody has, we're considering doing 3 additional webinars, one for each of these standards to do a deeper dive. If there are people interested, feel free to type in chat that you are interested, and then we'll go ahead and set that up for probably January and February. And then we did also put a link to a feedback survey in the chat. So if you do have a minute or two to fill that out for us, we'd love to get feedback on how these webinars are going. So again, if one more last call for questions, and then we'll wrap up if there are no additional. Great. I see a bunch of people interested in the deep dive webinars. So we will definitely get those set up for January and February. So keep an eye out we'll send out an email with registration links for those. Oh, we do have a question, and that is coming from
All right.
Sean. So Terry,
Okay.
you mentioned that SCR, FR, and DDR data may be needed to support PRC-29. However, PRC-28 is the standard that requires installation and configuration. Since there are different implementation dates for the standards, is the thought that you can use existing PRC-2 equipment under the retired standard until PRC-28 becomes effective?
And I use PRC-2 equipment until PRC-28 equipment becomes effective. Sean, I hope I'm going to answer your question correctly. And that is, there are some deadlines that are ahead of those equipment installation deadlines. But for PRC-29 and PRC-30, those implementation deadlines call back to each other. So 30 calls back to 29, 29 calls back to 28. And NERC, I believe, recognized that for my operational requirements, I can't perform PRC-29 or 30 until I install my disturbance monitoring equipment. So hopefully in the deadlines or your implementation plans, and hopefully I've got an example here, is you don't have to meet the operational requirements until the later of a certain date or when my disturbance monitoring equipment was installed. Did I answer your question, Sean? I hope I did. So you can use PRC-2 equipment if it meets the function, but I don't think you have to. I think PRC-29 and 30 operational requirements allow you to wait until your disturbance monitoring equipment is installed.
Great. Thanks, Terry. All right.
Uh,
Are there any additional questions? Otto, go ahead.
yes, I have a question. Let's see, for disturbance monitoring equipment, do you know if it is enough to have the relays that store the SCR, or do we have to, it's advisable to install like a Tesla or some other equipment that could actually store all the or centralize information from all the protection stored there?
I think I understand the question, which is I've got relays, they'll do the fault recording requirement. Can I use them or do I need a different piece of equipment? And it's okay to use relays. The technical issues that I wanted to point out is there may be some problems with the 2-second record length and with older relays. That doesn't mean you can't use them. You can certainly use them. You just want to make sure that they can meet the technical requirements in NERC standard PRC-28. Alternately, you can get a Tesla or another Schweitzer device to make, or a Mediatek device, which helps you meet these requirements. So if your relays meet the requirements, I think you can use them. Did I answer correctly?
Yes, I'll
Okay,
check the requirements. Thank you.
thank you. Thank you for the question.
All right, now we're really in the last call for questions. All right, seeing none. So just a quick reminder, if you can fill out our survey, that would be excellent. We would appreciate the feedback. And then I see a lot of people interested in those deep dive webinars. So like I said, we'll get those set up. We'll email out registration links and get those on the calendar for January, February timeline. Really appreciate everybody joining today. And if there are any follow-up questions, feel free to shoot an email over to us. And then we'll try and get back to you as soon as possible. Thanks, everybody.
Thank
Thank
you.
you, sir.
you
Thank you,
all.
everybody. We
Great work,
really
Terry.
appreciate it.